Hello NCU students, welcome to week 5. Guess what? Only 2 weeks left after this one. Yay! Alright, we're tackling 3 chapters this week though, and that comes with 3 quizzes. Only 1 case study you have to do of the 2. And then the business data analysis project, the primer, or the primer, however you say that. It's the first look at that project, and that's due this week. So it's a busy week and no time to slow down yet, or no time to take off, so don't even think about coasting yet. Let's look at the learning objectives for the inferential statistical tools that we're discussing this week. We're going to be reviewing the hypothesis testing from chapter 8. We'll be looking at the hypothesis testing from last week that we did, and then bolting on some more onto it this week as well. And just a heads up, if you look at the case study number 8, it does dip back into chapter 6 and 7. And if you look in the attend section, you can see some more about some guidance I give you there on doing that case study. But we'll also be looking at chapter 9 and learning how to do the chi-square statistical tool and when to use that. We're going to be looking at understanding the ANOVA, the analysis of one-way variance, out in chapter 9 as well. And then chapter 10 is all about linear regression and its statistical tool as well. In chapters 6 and 8 last week, we introduced the idea of a t-distribution. And last week we talked about using the t-test to evaluate the difference between the means of 2 independent groups, and then we learned about doing the paired t-test, where there's 2 groups are dependent on each other. We also learned about hypothesis testing. And this week, we are going to add on to the hypothesis testing using the z-test to assess the differences between 2 groups by inspecting the statistics of each of the group samples. Now, you may get a little confused about between when to use the z statistical tool and when to use the t statistical tool. I found a video that explains it quite well, so you can watch it for a little bit more fuller explanation. But here's a little hint, a little great test that comes out of that video and out of the statistics books that I have as well. If the size of your sample is greater than 30, you use the z tool. So the z tool, the z statistic tool, needs a sample larger than 30. In fact, the more the better. If it's less than 30, your samples are less than 30, use the t statistical tool. And just remember though, if you don't have a population's standard deviation to go from, you're going to need to use that t-distribution, t-statistical tool anyways. Levine, one of the authors of our stats book, says it this way. He says, as the sample size and degrees of freedom increases in a t-distribution, the sample mean becomes a better estimate of the population mean. And so the distribution gradually approaches the standardized normal distribution upon which the z calculation is built. So the t-distribution, the more and more samples you put in, the more degrees freedom, if you will, the more that t-curve, that t-distribution starts looking like the normal distribution. And then at some points, the t and the z at large samples look very similar to each other. So more than 30 samples, use z. Less than 30 samples, use the t-distribution. And the primary deciding factor pretty much is that sample size. Chapter 9, we're talking about the concept of the chi-square statistical tool. Sometimes we end up with these matrices, or these grids, if you will, of numbers that we need to compare. And they're often categorized. The course text offers some pretty good examples. And one of the examples that we can all relate to at some level, I think, is about fast food chains. Read about it on page 178 in the course text, but the premise is based on knowing if there's a difference in order accuracy between these 3 different chains that are shown in the example. So we have categories of data compared to other categories of data, or in this case, restaurants compared to order accuracy. And our question is often, are they the same or are they different? In other words, is the order accuracy the same at McDonald's and Wendy's and Burger King? Chi-square helps us to figure that out. To help you out in this, I found a video that's rather tedious, but it is helpful. And I also found some spreadsheets from the publisher that walks us through the examples that are in chapter 9. So you can find those in the attend section. They'll also tell you about the Excel functions that will help you out with that as well. Also in chapter 9 is the introduction to the statistical tool called one-way analysis of variance. In other words, ANOVA. Now that's not to be confused with the 1970s model car called Nova. I never had a Nova. I had a Pinto though. But an ANOVA tool is used when you are trying to understand the differences between means of more than two groups. Without hitting all the detail here, ANOVA calculations help us understand the difference between the members sampled from each group, usually three or more. All right, three or more groups you'd use in ANOVA. So you're looking to find the difference between the members sampled for each group and the difference between all of the sampled groups. So you become familiar with terms like variation due to differences within the group and variation due to differences among or between the groups. I found a pretty simple video by a guy with a gravelly voice to supplement that course text, so hopefully that'll help you out there. Chapter 10 dives into the world of linear regression. Now, to understand that statistical tool, you need to understand the relationship between independent and dependent variables. In brief, and if you've had 10th grade geometry, you've learned this already. In brief, independent variables are those variables that drive and predict the response of a dependent variable. So if you remember your basic line equation from, I said geometry, probably would have been basic algebra, but if you remember your basic line equation of y equals b plus mx, you're in the right territory because that equation is the model for linear regression, defining that relationship between x and y. Now, x is the independent variable and it floats along the x-axis, and y is the dependent variable floating up and down on the y-axis. It's being driven by x. M is the slope of the line, and B is called the y-intercept. Now, I found a pretty good series of instructional videos that walks you through those, and it takes pretty much through better part of chapter 10. I chunked them up a little bit. You can see those in the attend section, so they should line up with the course sections as well. Let's talk about your business data analysis project for a moment. Please be sure to read the guidelines in the syllabus. First of all, I need to tell you that. The primer for your business data analysis project is due at the end of this week, week 5. It's going to have 3 sections in it. It's going to have an overview of the organization. Your purpose in this section is to educate the reader. In this case, it's me, but it could be others. You will need to educate the reader about the business in which you're doing, in that research, where you're doing that research project. So tell the reader what that business is all about. What do they do? What service, what product, etc. Describe the problem that you're researching. Include research-based citations as well about the problem or topics related to the problem. So describe the problem that you want to tackle and go find some other places, some other research that's tackled those problems or similar to it, and tie them all together. Listen, it's okay. When you're describing this problem, stand on the shoulders of somebody else who's already done the work. Okay, and learn from them. Your purpose in this section, though, is to educate the reader about the problem you are solving. Third, describe the methodology that you're going to use to collect and analyze the data. This section will have a couple of subsections. Data collection methodology will be one of those subsections. Explain the variables that you're going to be working with and that you're going to be analyzing. Give definitions. What kinds of numbers are these? Or are they categories? Interval or ratio, are they continuous or discrete? Or are they categorical? Provide a written description of the variables, a couple sentences about as they relate to the problem that you're researching, back up in number 2 up there where you're describing the problem. Tell us what those variables are. Put them in real terms. Describe how you will get the data, interviewing people, current company documents, etc. Be sure you have permission from your employer or the business management team to collect and use that data. Then the other part of the methodology will be the statistical tools that you're planning on using. Describe the type of statistical tests that you're going to use. I encourage you to do more than just descriptive analysis of a single data set. All right? While it might get you a passing grade, you're not going to be able to demonstrate your full analytical skills. Choose something that has enough data that you can, enough of a problem that you can use descriptive and some inferential tools that we've been talking about in the last couple weeks. Okay, that's what's due at the end of week 5 for this data analysis primer. So no data collection or analysis, just describe what you're going to be doing. Now, as you consider your project, here's the bigger picture of the paper you're going to turn in at the end of week 7. Your business analysis project paper. Your final paper will have 5 sections that are shown here: the introduction, the methodology, the data analysis, the results, and the conclusions. Sections 1 and 2 should look very familiar because they're going to be basically the primer that you're turning in this week. You can rewrite that primer from this week so that you're not starting all the way from scratch when you write the final paper. Basically, sections 1 and 2 are already done. Let me give you a few guidelines about your project. Scope matters here. Do not try to solve world hunger. Hope you let me use that term loosely. Don't make your project so big that you can't get it done. You've got 3 weeks. Now, weeks 5, 6, and 7 to get this done. However, that said, don't make it so small that you barely meet the minimum requirements. As I read your primer documents that you turn in at the end of week 5, I'll try to give you some feedback on the scope. Does it seem about right? Is it too small? Is it too big? And that sort of thing. So you can still have some time to make adjustments. Pick something meaningful to you or the business that you're working with. Picking a meaningful project will keep you going when you're collecting and crunching data in the wee hours of the morning, which I'm sure some of you will be doing. Sometimes you just need that motivation, and picking something meaningful will keep you going. Get permission, again, to use the data from the business that you're working with. Involve the manager, the owner of the project, so they know what you're up to. And number 4, I know it sounds crazy, but have some fun with this. This is an opportunity to try out your statistical skills in a low-risk environment, so relax and enjoy the ride. I'll be alongside you to help you get through it. Okay, that's it for now. My virtual office hours, again, are on Wednesday evenings at 7 o'clock Pacific time. I'm also available at other times if you want to meet for a quick question via Zoom or whatever, phone conference. There are 2 case studies assigned this week, but again, remember, you only need to do 1 of them. I am praying for all of you guys. You can do this. God is on his throne. Remember that. He's always been there, and he always will be. Have a great day.